In probability, we have learned addition theorem of the probability and modified form of the addition theorem of the probability. Later we have discussed what is multiplication theorem of the probability. As we have discussed in multiplication theorem of the probability, that when events are independent with each other, then we will use multiplication theorem of the probability. In such kind of the condition, when one event haven't any effect on the second event, like if I am tossing a coin, suppose in first toss I am having the head, in second toss, if second times I am tossing the coin, there is no effect of the first head is over there, so the events are independent. Similarly, if I am throwing a dice and the upper value of the dice is 5, and second time I am throwing the dice, the first throw doesn't haven't any effect on the second throw is over there. So in such kind of the condition, we use the multiplication theorem of the probability. But sometimes one event have effect on the second event. Suppose from a pack of 52 card, I bring a card, and then I bring another card without replacement. It means firstly I have the card, now I am having second card from the pack of 52 card. So the first card whichever I have the effect on the second trial is over there. Suppose I am to pick a king from a pack of 52 card. First card I have drawn, if it is a king, then the probability of the next king is 3 upon 51. But if this is a normal card, then the probability of picking a second card, the king, is 4 upon 51. So when events are effect with each other, we will use the conditional probability. So in today's video, we will learn what is conditional probability and how we will use the conditional probability. So the probability of A and B, probability of A intersection B, that is probability of A multiplied by probability of B when A already happened. This is called the conditional probability. It means the probability of B is affected with the first event, which is we can say the probability of B is affected with the probability of A. In such kind of the condition, we will say that is a conditional probability. Similarly, probability of A intersection B intersection C, that is probability of A and probability of B when A had happened, and multiply the probability of C when A and B have happened. So in such kind of the condition, we will use the conditional probability of this. So here the probability A is independent event. Suppose from a pack of 52 card, we are drawing first card, that is independent event. But now we are picking second card from the same pack of the card of 52. Then the probability of B will affect with the probability of A. So it will be called conditional probability. Similarly, probability of A, probability of B when A has happened, and probability of C when A and B has happened. So this is the formula for the conditional probability. In today's video, we will having some questions related to the conditional probability. I am having, suppose from a pack of 52 card, two card drawn at a random. We are having some questions related to the conditional probability. One bag contains 6 red and 4 green ball. One bag contains, the first question of conditional probability, 6 red ball and 4 black ball. Suppose two balls taken from this without replacement, what is the probability that first will be red and second will black? Againly I am repeating the question. One bag contains 6 red ball and 4 black ball. Two ball one by one picked from this bag What is the probability that first ball will be red and second ball will be black? So getting first red ball, so the total ball is 10 and getting red ball is 6. Now we are not keeping the ball again in the box, in the bag. So getting probability of B when A is happened, that is 4 divided by 9. Here 9 is over there because firstly the 10 ball was in the bag, but one ball drawn, and without replacement we are having another one ball. So now the ball is 9 because one ball already we have taken, that is red ball. So the probability of red ball is 6 upon 10. Number of favorable event is 6 and total number of event is 10. But for the now the total number of event is 9 and the number of favorable event for the black is this. So probability of A intersection B, that is called probability of A multiplied by probability of B when A is happened. So that is 6 upon 10 multiply 4 upon 9. 3 2 ja 6, 3 3 ja 9. Okay. 2 2 ja 4, 2 5 ja 10. So that will be 4 upon 15. So in such kind of the conditions, we have to use the conditional probabilities over there. We are having some more questions related to this. Suppose one bag contains 5 red ball, 5 white ball and 5 black ball. Okay, one bag contains 3 types of ball. One is red, second one is white, third one is black. Okay, one by one ball is picked without replacement. It means once ball picked will never return to the box. So the very first, the one bag or box, whether bag or box, no problem at all. One bag contains 5 red ball, 5 white ball and 5 black ball. One ball 3 times pick from the bag. What is the probability that in first trial there will be a red ball, in second ball will be white and third one will be a black ball? So for total number of event is 15. So first one is red ball. So total number is 15 and 5 is red ball. Now without replacement second ball is taken. So probability of B when A event is happened. So the total number of event is 14 because one ball have picked. So probability of getting the white, that is 5, and probability of third ball when A and B is happened. So total number is 13 and the ball of black is, this is black ball, this is white ball and this is red ball. So probability of A intersection B intersection C, that is probability of A multiply probability of B when A is happened and probability of C when A and B is happened. So that will be 5 upon 15 multiply 5 upon 14 multiply 5 upon 13. So 5 3 ja 15. So there will be 25 divided by 3 multiply 14 multiply 13. So there will be 546. So the probability will be 25 divided by 546. This type of event is called conditional probability, when the probability of second event depend on the first event and probability of third event depend on the second event or first event. We will say it's a conditional probability. We are having some more question related to the conditional probability. We are one more questions related to this. From a 4 cards are drawn at a random from a pack of 52 cards. Find the probability that they are king, queen, jack and X. From a pack of 52 cards, 4 cards drawn at a random. What is the probability that will be a king, a queen, a jack and a egg? It means ताश की गड्डी से 4 पत्ते निकाले जाते हैं. क्या संभावना उसमें एक इक्का होगा, एक बादशाह होगा, एक बेगम होगा, एक गुलाम होगा. ओके, सो द probability of getting 52 cards, 4 cards from 52 cards, 52C4. Total number of event is, total number of card is 52 and we are picking 4 cards from the 52 cards, so we are having 52C4. So the probability of having one egg, that is 4C1, one king, that is 4C1, one queen, that is 4C1, one jack, that is 4C1, that is called probability. From a pack of 52 cards, 4 cards drawn at a random, not one by one, 4 cards drawn at a random. What is the probability that will be a king, that will be a egg, that will be a queen? There may be a king, queen, jack, egg. So that will be 4 upon 1 multiply by 4 upon 1, 4 upon 1, 4 upon 1 divided by 52 multiply 51 multiply 50 multiply 49 divided by 4 multiply 3 multiply 2 multiply 1. So 4 13 4 ja 52, 17 3 ja 51 and 25 this. So that will be, the answer of this will be 4 multiply this, that is 256 divided by 13 multiply 17 multiply 25 multiply 49. So the answer will be 270725. So the answer will be 256 divided by 270275. These questions are saying that from a pack of 52 cards, 4 cards drawn at a random. But this question are in this form, that from a pack of 52 cards, 4 cards picked one by one. Okay. What is the probability that the first will be egg, second will be king, third one will be queen and fourth one will be jack? So for picking first king, that is 4 upon 52. For probability of B, that is king, depend on 4 upon 51 because the replacement is not over there. From a pack of 52 cards, 4 cards picked one by one without replacement. It means one card picked will never return to the box. Okay. So the probability of getting first king, that is 4 upon 52. Probability of getting queen in second, first is egg. Second one is king. Then queen. So probability of C when A and B is happened. So queen is 4 and total card is 50. And probability of getting jack. Probability of D when A, B and C is happened. So that is 4 upon 49. So probability of A intersection B intersection C intersection D, that is called probability of A, multiply by probability of B when A is happened and probability of C when AB is happened and probability of D when ABC is happened. So that will be 4 upon 52 multiply 4 upon 51 multiply 4 upon 50 multiply 4 upon 49. So this will be different answer. So 256 divided by 52 multiply 51 multiply 50 multiply 49. So 6497 400. So in probability we have to learn what the question is asking. We have go through each question is asking, then our probability will be correct. So the same question is over there, but 4 card drawn at a random, then the answer will be different. And 4 card drawn one by one without replacement, then the answer will be different. Otherwise, we are having same answer is same question is over there. From a pack of 52 card, 4 card drawn at a random, what is the probability that there will be a king, a queen, a jack? Here also we are having from a pack of 52 cards, 4 card one by one drawn at a one by one drawn. What is that? That the first one will be king, second one will first one will be egg, second one will be king, third one will be queen, and fourth one will be jack. So the difference is over there. So in probability, you have to learn what the language is asking. Similarly, you have go through with the language, you will having the answer of this. One more question related to the probability of conditional probability. So it's very important that what question language is over there. We have to careful about the language of the question is over there. From a pack of 52 cards, one by one 3 cards drawn, what is the probability that will be a king, queen, and a jack? If one card drawn never written, already we have done this question. From a pack of 52 card, 4 card drawn one by one, what is the probability that all card will be have different suit? Okay. From a pack of 52 card, againly I am repeating the question, 4 card drawn one by one without replacement. What is the probability that all card have different suit? Okay. So probability of getting first card, that is 52 by 52, because all different suit may be. Suppose in probability first we are having, there may be club, there may be heart, there may be diamond, and there may be spade. Suppose here we get spade. Now probability of B, when age happened, without replacement is over there. So total number of event is 51. But favorable is now 3. There may be club, there may be heart, there may be diamond. So the total favorable event is 39. Suppose here heart card is okay. So probability of C, when A and B is happened, so there will be 26 upon 50. Like the probability of having club and having diamond. Suppose here diamond is come. So now probability of D, when A, B and C is happened, so that is 13 upon 49, and here may be the spade is over there. So from a pack of 52 card, 4 card drawn one by one, what is the probability that all card have different suits? So the first have we have 13 this, 13 this, 13 that, so there will be 52 upon 52. Now suppose here the club is come. Now we have 3 opportunity. There may be spade, there may be heart, there may be diamond. Suppose in this second throw heart come out. So we have 2 probability. There may be spade or diamond. Suppose in third diamond is over there. So we are having only 1 probability that spade may become. So that is spade. So the probability of A intersection B intersection C intersection D, that is called probability of A. Probability of B when A is happened. Probability of C when AB is happened, and probability of D when ABC is happened. So that will be 52 upon 52. Multiply 39 upon 51. Multiply 26 upon 50. Multiply 13 upon 49. So 52, 52 cross. 3 1 ja 3, 3 3 ja 9, 17 3 ja 51. 13 2 ja 26, 25 2 ja 50. Okay. So there is 13 multiply 13 multiply 13. 13 multiply 13 multiply 13. So 2197 divided by 17 multiply 25 multiply 49. So that will be 20825. So these questions are dependent on the conditional probability. Similarly, we are having another question related to the conditional probability. From a pack of 52 cards, 4 cards drawn one by one without replacement. What is the probability that all 4 cards are same value? It means if king is over there, all the king. If queen is over there, all the queen. If 10 is over there, all should be 10. If 5 is over there, all should be 5. Okay. So againly I am repeating, from a pack of 52 cards, 4 cards drawn one by one without replacement. It means once card drawn will not never mix in total number of cards. What is the probability? All cards will have same value. It means if one is king, other all will be king. If one is 10, all other all will be 10. So probability of getting first card, that is 52 upon 52. There may be 8, there may be jack, there may be queen, there may be king, there may be 2, 3, 4, 5, 6, 7, 8, whatever. Okay. So the first card, the probability of the first card will be 52 divided by 52. Okay. In second probability we have to calculate. Suppose this card is 10. So the probability of B when A is happened, now 10 is 110 is taken, so 310 is over there and total card is 51. Now probability of C when AB is happened, so only 210 is over there, total card is 50. And probability of D when ABC is happened, that is 1 upon 50. If 10 is over there, 52 by 52, then 10 is 3, then 10 is 2, then 10 is 1. If here king is over there, so first will be 52 upon 52, then 3 king is over there, 2 king is over there, 1 king is over there. So the probability of A intersection B intersection C intersection D, that is 52 upon 52 multiply by 3 upon 51, 2 upon 50 and 1 upon 49, sorry. So this cancel 17 times, 25 times. So that is 17 multiply 25 multiply 49, 20825. So that is 1 upon 20825. So this will be the probability. So in this manner we can having some questions of probability. From a pack of 52 cards, 3 cards drawn at a random. 3 cards drawn at a random. What will be the probability? That will be the king of heart, queen of heart and jack of heart. Againly I am repeating. From a pack of 52 cards, 3 cards drawn one by one without replacement. What is the probability that in first there will be king of heart, in second there will be a queen of heart and third there will be jack of heart. Okay. So first the king of heart. So first king of heart, that is having 1 upon 52. Only one king of heart is over there. So king of heart is over there. And second without replacement is over there. So total number of event is 51 and that is also 1, that is queen of heart. Probability of B when A is happened. And probability of C when AB is happened. So there is also, that is jack of heart. So probability of A intersection B intersection C, that is probability of A multiply by probability of B multiply by B when A is happened, and probability of C when AB is happened. So that is 1 upon 52 multiply 1 upon 51 multiply 1 upon 50. So in this manner we can solve this question, that is 52 multiply 51 multiply 50, that is 132600. 13260. So this will be the probability of this. So in any condition of the probability is over there. This is called conditional probability. When one event, happening of one event affect the happening of second event, then we will use the conditional probability. We will having some more questions related to the conditional probability in next video. So I think this video will be helpful for you to know how to solve the conditional probability. Thank you once again.